The nucleus, part 3. We're going to talk about the dimensions and the density of the nucleus. We'll start by its dimensions. We know that the nucleus is formed of protons and neutrons. The nucleus, XAZ, is formed of Z protons and N neutrons. The total number of nucleons is A. The nucleons are the protons and neutrons. Then, as a whole, A is the protons and neutrons. We'll assume that each nucleon, whether it was a proton or neutron, has a spherical form of radius r0 equals to 1.2 Fermi. The radius of a nucleon, that is to say, a proton or a neutron, assumed spherical, of course, we assume that the nucleon is a sphere. How much is its radius? R0 equals to 1.2 Fermi. What is the Fermi? The Fermi is 10 exponent minus 15 meters. What is the volume of a nucleon? The nucleon is assumed to be spherical. We know that the volume of the sphere is 4/3 pi r cubed. And this sphere has a radius r0. Hence, we'll associate to each nucleon a volume V0. This is the volume of a nucleon. This is an approximation. The nucleus is also assumed to be a sphere of radius r. The radius of a nucleus, assumed spherical, we'll also assume that the nucleus is a sphere. The radius is r. What is now the value of r? The nucleon is known. All nucleons are assimilated to spheres of known or well-estimated radii, 1.2 Fermi. The radius of a nucleus, on the other hand, depends on the number of its protons and neutrons, or the number of its nucleons. The radius of the nucleus isn't fixed. The radius of the nucleon is fixed. A nucleon is a proton or a neutron, whose dimensions are approximately the same. Each nucleon, a proton or neutron, has a radius of 1.2 Fermi. How can we determine or estimate r? What is the approximate value of r? Note that the nucleus is a sphere containing A nucleons. Each nucleon has a radius r0 and a volume V0. The volume of this is V0, the volume of this is V0, the volume of this is V0, and so on. The nucleus, as a whole, is a sphere of radius r to be determined. If V is the volume of the nucleus, it is the volume of this sphere. This sphere contains A nucleons. Then, the volumes V0 are found inside. How many volumes V0 do we have inside? We have A V0. A is the number of nucleons multiplied by the volume of a nucleon. So we get the total volume of the nucleus. The volume of a sphere of radius r, or of the nucleus of radius r, is 4/3 pi r cubed. This is equal to A multiplied by 4 over 3 pi R0 cubed. R0 and V0 are associated to one nucleon. Now by simplifying, we obtain R cubed equals to A R0 cubed. Perform the cubic root on both sides. We obtain R equals to the cubic root of A multiplied by R0. So we can write R equals to R0 multiplied by A exponent to 1 over 3. This is to be memorized. The radius of the nucleus can be always known when knowing the radius of one nucleon, which is fixed, multiplied by the cubic root of the mass number of the nucleus. Hence, the nucleus is formed of nucleons. Each nucleon is assumed a sphere of radius 1.2 Fermi. The radius of a nucleus depends on the number of its nucleons. The radius of a nucleus is given by this relation. R0 is always 1.2 Fermi. The Fermi is 10 exponent minus 15 meters. Now for some applications. Calculate the radius of the O816 nucleus. The radius of a nucleus is given by R equals to R0 A exponent 1 over 3. A is the mass number, which is 16 in this case. 1.2 Fermi. R will be in Fermi as well. 16 exponent 1 over 3. The result is 3.02 Fermi. The radius of the oxygen nucleus is 3.02 Fermi. This is an approximate value. It is not the exact value, but an estimation. Calculate the mass number of a nucleus of radius 4.8 Fermi. The radius is 4.8 Fermi. The mass number of this nucleus is A. We have to determine A, knowing the radius of the nucleus. We also use the same formula, R equals to R0 multiplied by A exponent 1 over 3. A exponent 1 over 3 equals to R over to R0. We cube both sides. We obtain A exponent 3 over 3. This equals to R over R0 exponent 3. As a result, A equals to R over R0 exponent 3. R is 4.8 Fermi. R0 is 1.2 Fermi, all exponent 3. Simplifying, the result is 4 exponent 3, which is 64. As a result, A equals to 64. The nucleus that has a radius of 4.8 Fermi has 64 nucleons.